And for this presentation, we actually do not have our guest. They couldn't make it, yet he thought it was so important to make sure you had the content that he pre-recorded it. Anton, me and names are so bad, my apologies. Shchekalov we're going to be watching a video from him about best practices for managing webhooks at scale. And he is the VP for engineering at CPaaS at 8x8. So thank you so much for joining us for his pre-record, and we will not be doing Q&A for this one. You can reach out to him and reach out to us at API Days to be able to ask questions that we can post later on.
Hello, I'm glad to be a speaker at Apidays conference. First of all, thanks to organizers for the work that you do. There is a lot of valuable content on your YouTube channel collected from speakers around the world. I'm going to share today my knowledge about best practices for managing webhooks at scale. Webhooks require a lot more engineering time, resources, and ongoing maintenance than you would first expect. Building a secure, reliable, and scalable webhook service is hard and time-consuming. The reason for this presentation: in my company, as a part of wider initiative to improve the developer experience of our customers, we made a research a few months ago to answer a question: what additional features we can bring to our products to improve webhook management for benefits of our clients, to be a more developer-friendly service. For this purpose, we have compiled a list of all best practices, and I'm happy to share those findings with you today. As for our team, we cross out what we have and define a roadmap for the next product improvements. Before, a few words about me. I worked in the telecom and messaging industries most of my career, from a time we were selling ringtones for Nokia and Motorola phones. Who remember those times? And all of the time I was building API-driven services. Now I'm happy to be based in Singapore. I don't know any other country where the most recognizable landscape is a hotel with a pool on the roof. I'm working at an awesome company, 8x8, as VP of Engineering for CPaaS, which stands for Communication Platform as a Service. My role is to build engineering teams and lead the development of CPaaS products inside 8x8 for the global market. It's my second speech at API Days conference. Before COVID times, I was doing an overview of what companies have to do to build a successful product on top of API. That's a list of topics that I'm going to cover in the next 20 minutes. And let me start with the introduction. How closely 8x8 is working with APIs. You probably know customers today expect a top-notch experience. As they navigate through multiple channels and platforms, they expect a consistently great service. Contextual communications across customer engagement and support functions is a new norm. And this is where 8x8 comes in. We're a leading SaaS provider for voice, video, contact center, and communication APIs, powered by a global cloud communication platform. From our cloud technology platform, organizations across all their locations and employees have access to unified communications, team collaboration, video conferencing, contact center, and programmable communication, enabling them to be more productive and responsive to their end users. Our customers range from small businesses to large enterprises, and their users are spread across more than 190 countries. Today I'll be focusing on 8x8 API services. We help brands to deliver billions of messages and calls in a year to their end users in a programmable way. They call our APIs dozens of millions times every day to engage with users. And the variety of use cases how to use communication API is huge, from sending OTP SMS, reminding a WhatsApp or Viber about upcoming delivery or booking, initiating a phone call between taxi driver and a passenger, or bringing a doctor and a patient in a video call. What is common among these scenarios? Communication is two-way and asynchronous. This is where webhooks or reverse API come into play. So now you can imagine the scale that we send millions of events to thousands of URLs of third-party applications every day. Webhooks provide a powerful method to track the state of operations and take actions in real time. If the client is interested in knowing if a resource is in a completed state, the client would have to keep sending requests until the status is completed. This approach, that called pooling, can be highly inefficient. And if the status changes unpredictably, with the long delays, a lot of CPU and network resources will be wasted on both client and server sides. According to one survey, 80% of developers prefer to consume a third-party REST API by being notified of changes via webhooks instead of pooling. Well, because pooling requires developers to maintain state and infrastructure. But don't get me wrong, to my surprise, a few years ago we had a large e-commerce customer who insisted to use pooling approach due to their architecture and security constraints. They combine now APIs just to get the message delivery statuses. Let's start with the basics. Webhooks is a URL that's publicly accessible on the internet. Therefore, whenever there is a request that hits the URL, it's important to ensure that the request truly came from expected sender. Without such verification, attacker can fake request sent to the client. Currently, there is no standard on how to secure webhooks. However, all widely used authentication solutions works well. Basic authentication, API key, or else. During your product lifecycle, together with the evolution of API, a payload of your webhooks will be evolving too. Version for webhooks is a must-have. But in comparison with version of API endpoints, where you publish a new version and expect new incoming requests, the preferred version of webhook must be stored in your database, together with the URL of the hook. And you have to allow a customer to change the version whenever he's ready to upgrade, ideally in a self-service way. In addition, the concept of webhook versions simplified for us a custom third-party integration. It's not necessary to have only one active and latest version of webhook payload. For the benefits of integration with another SaaS platform, you can perform an adaptation of events on your site and tag it with a specific version. Quite typical scenario is when your product sends only one event type initially, but over the time, platform will be growing and sending multiple event types, and probably some customer will ask you to separate URLs for each event type. The most flexible model will be multiple events and multiple webhooks. And finally, be your first customer. APIs webhooks are used by developers with their own preference of programming language and coding skills. While you design the webhook for another developer to integrate in their platform, you need to put yourself in his shoes and see how easy it is to integrate this payload. Can the webhook's payload be always parsed using the same domain model, despite versioning? How do you send null values for integer fields, for example? Does your documentation contain all the details about conditions that they change the webhook object? Now we are going to talk about more interesting topics. As a SaaS company, if you have a target and ambition to join the ecosystem around you to support hundreds and thousands of developers and speed up their onboarding time, be ready to give them as much flexibility as possible. You would need to build a UI, obviously, for users to edit endpoints, change their version, other settings, maybe subscribe to particular events only, and generate a secret for your signature. Few enterprise customers ask us to provide the same functionality of API. They want to programmatically rotate authentication keys of their webhook for security compliance reasons. It also worth investing time upfront to build a library of sample events you would want to send out via webhooks. Otherwise, developers get stuck needing to trigger things in your service or worse via external providers. Schema and samples must be described on a developer portal together with API specification. Maybe add a Postman collection and ideally an online tool in your self-service portal that generate test events. And the last one, to be super friendly to other developers and third-party apps, all kind of webhook customization welcome, starting from a simple HTTP GET or POST, adding custom headers for authentication key, Customization of URL itself depending on the object. Some services even provide a builder to fully transform a payload. We live globally connected, but sometimes those connections don't work. Even services with a billion users can go offline. Don't expect customer webhooks to have 100% uptime. This is normal. A page got thousands of failed webhook calls in a minute in production. Customer endpoint is temporarily down, expired certificate, timeouts, invalid URL. So interesting situation that as API providers, we are responsible to take care of their failures because we take over the responsibility to deliver updates to the clients. So the API provider has to deal with retry policies to their best extent. Best practices. Obviously use exponential backoff to slowly increase the time between your retries. This stops your webhooks from causing an unintentional denial of service attack on your clients. To avoid large wait periods, set a maximum backoff time, usually 1 day. If an endpoint hasn't been responding for a while, mark it as broken in your endpoint database and stop sending requests to it. Once you have marked an endpoint as broken, send an email to the developer notifying them that you have been unable to reach the endpoint and they need to fix it. We do it in a friendly way. We send a warning email initially when the error rate of endpoint is above 90% in the first 3 days. The email also states when the endpoint will be automatically disabled. And if it wasn't recovered in the subsequent 3 days, we send a final email reminder and disable endpoint. Few advanced features that could be also added. With respect to other developers, you can also support their retry after response header from HTTP error 429 to many requests. If a customer wants to slow down throughput. We also keep an internal setting for timeout of each endpoint. We don't show it to customers, but we tweak it sometimes to fail early and release the threads to the shared pool. Depending on your use case, it could be nice to add the capabilities for customer to run data reconciliation jobs, because real-time streaming of events is not always reliable. A customer should be able to fetch data periodically, but within limited quota on these operations to avoid the pooling style. I guess majority of engineers like to deal with a high load, but it comes with its own challenges. When you send out millions of events every day to a large number of customers. First of all, no doubt, queue-based system with a persistent storage is required to handle large volume of traffic. It gives abilities for buffering, it's more memory safe, and none of events is lost during a service restarts. It could be a search service RabbitMQ, Kafka cluster, or use a cloud solutions like AWS SQS or Google Cloud PubSubs. We use multi-tunnel architecture and regularly serve large marketing campaigns. It means we have to deal with more accurate resource governance and distribution among customers. We have to segregate and prioritize different customer streams. When there is a spike of events towards one client, we must guarantee minimum delay of events to other endpoints. A good recommendation is to define a default throughput quota for each endpoint. We don't know their initial capacity, and we don't want to create an overload for them. We experience both types of cases when we have to increase or decrease amount of requests per second. Another problem that appears periodically, imagine a customer with a large traffic flow that starts to respond slowly suddenly, let's say 10 seconds for response. It may lead to a situation that a high percentage of threads from a shared thread pool will be stuck, and it creates a congestion for other clients. Just a month ago, we had a perfect example. One customer sent a large messaging campaign with about 10 million SMS via a well-known CRM platform, and it was received well on our side in a very short time. It generated even a larger volume of SMS delivery events back to the CRM platform. But their webhook had a 1 second response time. We can do the math. With the configuration of 100 concurrent requests, it will take more than 27 hours to deliver 10 million events. And there is no reason to increase outgoing throughput for them. But delivery to other clients must not be impacted. Moving to security considerations. How HTTP traffic on Webhook looks like. It goes with a high frequency from a same source IP address. If a customer is using a web firewall on their side, and they should do it, the traffic can be recognized as suspicious, harmful, and eventually blocked. One of our client, a unicorn company, spent a couple of days to investigate why about 10% of the traffic to them was failing periodically. And the reason was in the IP rate limiting rule. So I highly recommend using a NAT for outgoing traffic and publish your IP list in the developer portal so the customer can whitelist it in their firewall if they have to. Obviously, accept only HTTPS endpoint URLs for privacy and data integrity. Also, add a signature header to your request using a hash-based message verification method. It allows a client to verify the sender of a message that he knows the secret key. What is replay attack? It's when an attacker intercepts a valid payload and its signature and then retransmit them again. To mitigate such attacks, a timestamp has to be included in the signature header. If a signature is valid but the timestamp is too old, a client application can reject the payload. There is always a bad guy who will try to probe internal infrastructure using a webhook URL, so it must be properly validated. It's called a server-side request forgery vulnerability. Also prevent resource exhaustion from misbehaved webhook receivers by discarding response headers and bodies that are excessively long. We're just looking for a 200 OK response code. If sending events to a customer is an important element of a product, it's going to be so cool to step up a developer experience by creating a dashboard with the metrics of their webhook performance. Show the volume of events, history of error rate, and response time. Show the log of a last failed requests. Those metrics can be collected on the sender side only. It makes a product consistent, transparent, and complete. It motivates developer to improve the stability and response type of webhooks. It accelerates the troubleshooting of integration issues. In applications with very intensive event flow, API providers can add support for more efficient event-driven protocols. However, it might be overkill in the majority of typical use cases of business-to-business communication. So the web has standardized asynchronous communication via webhooks, protocols, and HTTP streaming. There are also modern GraphQL and gRPC technologies to explore. WebSockets allow to establish long-living TCP connections with low-latency communication. This is a huge plus. And also because you don't have to send multiple requests, you end up saving on the overhead of HTTP requests like their headers or TLS handshakes. However, clients become responsible for driving the lifespan of connections. They need to take care of recovery if a connection dies. It also can be difficult to scale things on the server side since the clients are establishing a single connection. So the webhooks are great for certain use cases only, not for everyone. They come with their challenges. What is HTTP streaming or server-side events? With typical APIs, the server returns an HTTP response of a fixed length, and it's possible to make it indefinite. And this is the idea behind HTTP streaming. The server continues to push data in a single long-lived HTTP connection. The response is indefinite, so the server keeps sending more and more data. Let's summarize. Calling webhooks at scale requires a lot of engineering time. Building a reliable, scalable webhook service could be hard and time-consuming. I hope I tried to describe it from all angles. Good thing, there are commercial SaaS and self-hosted solutions on the market that focus on to take care of webhook delivery. That's all that I have. Thank you for listening. I hope it was helpful and it will make your customers happy in the same spirit that Apidays is trying to achieve.